Hi. So in this session, we need to work on three more patterns, and the patterns have a little different shape than what we have seen so far, right? So nothing major, nothing really hard. It's just a little change on what we have seen so far. Okay, so the patterns that we want to work on, they basically look like this. Sorry, the first pattern looks like this. So very similar to something that we have already seen. We have already seen this pattern, right? So similar pattern, but it seems like we don't want these entries. We just want this side of the actual pattern, the earlier pattern. We don't want these entries. Okay, so that's the first pattern. The second pattern we want to work on looks like this. These are again all examples of n is equals to 4. The third pattern we want to work on looks like this. So a little different from this one, right? The numbers are a little different. So we'll come to each of them and we'll see what exactly is going on. So if you look at this pattern, let's answer our three questions. How many rows? I think n rows. Right? If n is 4, we have 4 rows in all of them. Now, what about number of columns in ith row? Now, that's the interesting part. Here, the first row has 1 column. The second row has 2 columns. The third row has 3 columns, and the fourth row has 4 columns. The ith row will have I columns. So the ith row will have I columns. So that's something that we need to look at. So it's not n columns anymore, it's I columns. So each row has different number of columns, and that's something that we need to take care of. What to print? In the first example, I think it's very straightforward. We have already seen it. First column values are 1, the second column values are 2, the third column values are 3, and the fourth column values are 4. So I think we need to print j. That's what we need to print, right? So in the ith row, you will have I columns. In those I columns, the first column will be 1, the second column will be 2, the ith column will be I. That's it. That's the standard simple answer for what we need to print for the first pattern. So let's quickly write code for that, and we'll come to the second and the third one pretty soon. So let's quickly move. Okay. So let me quickly make a copy of this. Let's paste it. I love the fact that it numbers automatically. It's automatically naming it pattern 5. Perfect. So in pattern 5, we were printing j, but this was a square pattern. What I mean by that is, if I was giving 4, it was printing 4 entries in each row, 4 columns in each row. That's not what you want. You still want n rows. You still want to print j. What you don't want n columns. You want this to be I columns. Ith row will have I columns and not n columns. That's the only change we need to do for this particular pattern, right? So we have n rows, ith row has I columns. What do we need to print? The column number. That's it. So what's going to happen is, in the third row, let's say n is 4, in the third row what's going to happen is, you will have only 3 entries, because the loop is going to run only 3 times. Starting from 1, it will go till 3, at 4 it will stop and it will print 1, 2, 3. In the second row, it will go till 2, so it will print 1, 2. In the first row, it will print only 1. In the fourth row, it will print 1, 2, 3, 4 because it has 4 columns. And that's exactly what we need. Let's run this. Right, let's give it 4, and that's exactly what we wanted. So seems to work absolutely fine, right? Okay, now let's move to this pattern. I think this is same. N rows, ith row has I columns, right? So these two are exactly the same. What has changed? What we need to print. Honestly, it doesn't look like that we can print the row number, because all the numbers are different. We can't print the row number, we can't print the column number, so we need to find some other way. And if you look closely, what's happening is, first you print 1, then you print 2, then you print 3, then you print 4, then 5, then 6, then 7, then 8, then 9, and then 10. So you start from 1, and as soon as you print that, you increment it, and next time you print the next value. So I think a better way of writing this pattern, writing code for this pattern would be, let's have a P, not I, not J. Let's have a P which starts from 1, right? We never reset it. It starts from 1, it keeps increasing, and we keep printing it. So we are going to decide the structure using these two values. We know we will have n rows, we know we will have, each row will have I columns. So the structure will be defined using these two values, but what we need to print will basically be a P value which will start from 1, and after every print we will keep bumping it one more, so that the next time what it prints is one more than what it printed previous time, right? Okay, perfect. So let's see what we need to do. So I'm just going to copy this and I'm going to paste this pattern 6. Let's open pattern 6. Okay, so right now what it is doing is it's creating a pattern of this shape. That's exactly what we want here as well. The pattern has to be of this shape, but what's different is what we need to print. So initially if I make P is equals to 1 and I print P, and as soon as I print P, I'll make P is equals to 2. Next time when I have to print, I'll print 2 and I'll make it 3. Next time I'll print 3. Then again after printing 3, I make it 4. So next time whenever I have to print, I'll print 4. That's how I want to work on this pattern. So what I'm suggesting is, let's create another variable, initialize it to 1. Instead of printing J or anything else, let's print P. So right now, if I don't change anything else, what's going to happen is you'll get the same shape, but it will be all 1 values, because P is 1 and you are never changing 1. You are never changing P. But if after printing P one time, I make it 2, next time it will print 2. And as soon as I print 2, I make it 3, next time it will print 3. And if I keep doing that, I think I'll get my desired pattern. So it's very, very simple. As soon as you print P, increment P by 1. Now what will happen is, whenever you print a value, next time you will print one higher value. That's exactly what we need here, right? So let's run this. Let's give it value 4. Exactly what we needed. Exactly what we needed, right? So we wanted P to start from 1 and we wanted it to keep increasing as we are progressing through rows and columns, and that's exactly what we have done, right? Seems like we are done with pattern 6 as well. So this was done earlier, this is done as well. Now what about this? In this one, P starts from 1, okay? It goes to 2, it goes to 3. The problem is, it comes back to 3. It goes to 4, goes to 5. The problem is it comes back to 4. So it doesn't look like that P can keep increasing, right? Seems like P has to change its value and reset to something else and then start increasing again. So for the first row, it starts from 1, that's perfect. The second row, it starts from 2 and keeps increasing, right? Third row, it cannot go to 4 because 3 is already printed. In our previous logic, we'll go to 4. In the third row, it actually has to come back to 3. It has to come back to I. So what we need to print is, instead of saying P is equals to 1 and keeps going up, I think in ith row, P will start from I. In third row, it will start from 3. In fourth row, it will start from 4 and it will keep going up. So the difference here is, here we initialized P one time and we kept increasing it. I think here we need to increase P, but one thing we need to do is we need to pull it back at the starting of each row. In the third row, it needs to start from 3. In the fourth row, it needs to start from 4. In the fifth row, it will have to start from 5, right? So again, the only change is, let me copy this. I think the only change is, this is all perfect. Whenever you go inside this loop for some value of I think P needs to start from I, right? What that will do is, even if in the previous row P went to, let's say, a 3, 4, 5, and it has actually reached 6 because 5 was printed, we will not start printing here from 6. we will start printing here from 4, because in the 4th row we are pulling P back to 4, right? We are getting P back to 4. So I think the only change we need to do here is this. So for the ith row, pull P back to I and then let it increase for that particular row. For the next row, we will again pull it back and then start from there, and it'll keep going up, right? You can also do this, you can get rid of P declaration from here and you can just declare P here itself. So every time when I come inside a particular row, I'll start a P, I'll create a P which starts from I and keeps going up. So it seems like P is not a universal thing which was true for all the rows, right? In the previous example, it was true for all the rows. Whatever was printed in the last row, you had to start from the same place. Here, it's different. For ith row, I don't care what happened in I minus 1 row. In ith row, I start from I and I print I columns. That's what we are doing here. Okay? Perfect. So let's quickly, for n is equals to 3, let's dry run this. N is 3, I is initially 1. Because I is 1, P becomes 1, J starts from 1. 1 is less than equal to 1. So we print P, that is we print 1, right? So you are comparing J and I. So 1 is less than equal to 1, so you printed P. You made this 2 and you made this 2. As soon as J is 2, 2 is not less than equal to 1. So you print and enter, you move to the next line and you make it 2. As soon as I is 2, we create P which is 2. We make J which is 1. 1 is less than equal to 2, so we print P. So we print 2 and we increment P by 1, we increment J by 1. J is still less than equal to I, so we print P, we increase P by 1 and we increment J by 1. 3 is not less than equal to 2. So this loop is over, we come to the next line, we increment I by 1. So I is 3 now. Now P starts from 3. P was 4 already, but now P is not 4. P is starting from 3 because P is I. So P starts from 3, J starts from 1, 1 is less than equal to 3, so you print 3 and you, after printing 3 you make it 4, you make it 2. So 2 is less than equal to 3, so you print P, P becomes 5, J becomes 3, 3 is less than equal to 3, so you print P which is 5, P becomes 6, J becomes 4, 4 is not less than equal to 3, so you are done. Seems like it is working fine. Let's quickly try it for one more row. So let's say n was 4. So 3 now has gone to 4. 4 is still less than equal to 4, right? So you will still go and print the 4th row. J starts from 1. P has reached 6, but now P will again start from 4 because P starts from I. So what will happen? 1 is less than equal to 4. You will print P. So you print 4. This becomes 5. This becomes 2. For the same logic, you will print 5, 6, and 7. That's exactly the pattern we were looking for. The catch here is P is reinitialized from I every time you start a new row. Okay, perfect. Let's run this. That's exactly what we wanted, and that's exactly what we got. Perfect. Seems like this works fine as well. Great. I think now we have solved very interesting patterns, and hopefully you will be able to do more practice. In the next session, we will look at really interesting pattern. I think that will basically open up, that will allow you to work on very, very interesting patterns from a lot of different places. So in the assignments, as well as if you want to practice somewhere online, you'll find a lot of examples where you'll be using patterns like these and patterns that we'll be discussing in the next session. Okay, thank you.